So the table shows the number of apples A that Lucinda uses in B batches of applesauce. Graph the relationship between batches B and apples A, then write the equation that shows the relationship. So it says one batch is 4 apples, so one batch, 4 apples. 2 batches, 8 apples. 3 batches, 12 apples. And 4 batches, 16 apples. And then I have to write an equation. So my equation would be A equals 4 times the number of batches. Would be their number of apples. It's 4 times your batches to get to your apples. Okay, number 12. Delona walks 4 miles per day for exercise. The total number of miles M that she walks equals 4 times the number of days D she walks. What is the dependent variable? So my dependent variable is going to be the total miles that she's walking. What is the independent variable? The independent variable is D, the number of days that she walks. Then I need to write an equation that represents the relationship between M and D. So my number of miles equals 4 times the number of days. That would be my equation. Number 13. Lacey is staying at a hotel that costs $85 per night. The total cost of Lacey's stay is 85 times the number of nights in that she stays. For numbers 13a through 13d, select true or false for each statement. So 13a, the number of nights in is dependent on the cost. No, that's false. Because the cost depends on the number of nights, so it's backwards. 13b, in is the independent variable. That's true. The number of nights is independent. C, the cost is the dependent variable. That's true. The next one says the equation that represents the total cost is C. The total cost equals $85 per night. That would be true. Number 14. A taxi cab company charges an initial fee of $5 and then $4 per mile for a ride. Use the equation C equals 4x plus 5 to complete the table. So I am going to use 4 times 2, because my first one is 2, plus 5. So 8 plus 5 is $13. Next one, I'm going to substitute the 4. 4 times 4 plus 5, so it's 16 plus 5 is 21. Next one, I'm going to substitute in my 6. 4 times 6 is 24 plus 5 is 29. And then I'm going to substitute in my 8. 4 times 8 plus 5. So 4 times 8 is 32 plus 5 is 37. For 8 hours, or 8 miles. Okay, number 15. A grocery display of cans is arranged in the form of a pyramid with 1 can in the top row, 3 in the second row from the top, 5 in the third row, and 7 in the fourth row. The total number of cans C equals 2 times the row R minus 1. Use the equation C equals 2R minus 1 to complete the table. So then I'm going to substitute in a 5. So I'm going to go 2 times 5 minus 1 to get how many cans are in row 5. So it's going to be 10 minus 1 is 9. Then I'm going to substitute in a 6. So it's going to be 12 minus 1, 11. Then I'm going to substitute in a 7. 14 minus 1, 13. Then I'm going to substitute an 8. 2 times 8 is 16 minus 1, 15. Okay, number 16. The graph shows the number of words Mason read in a given amount of minutes. If Mason continues to read at the same rate, how many words will he have read in 5 minutes? So we can see if we're looking at patterns in the table. In 1 minute, he read 200. 2, he read 400. 3, 600. So it's increasing by 200 each time. So if in the 5th minute, if I increase 200 from 8, I'm going to get to 1,000. So in 5 minutes, he read 1,000 words. And that would stay on your linear graph. You can see that it's exactly part of your linear graph. Okay, last question, number 17. Casey claims the linear equation for the relationship shown by the graph is C equals 25J. Use numbers and words to support Casey's claim. So if I look at my ordered pairs, I see 125, 375, 5, 125, 7, 175. If I go 1 times 25, I get 25. So I can substitute it in here in my ordered pairs. 3 times 25 equals 75. 5 times 25 equals 125. So I can substitute in this equation with these numbers and it works every time. So it would show that this is true. So I would just say the ordered pairs 1 to 25, 3 to 75, 5 to 125, and 7 to 175 each make this equation C equals 25J true. And that's it. If you have any questions, you can leave me a message on the classroom. Thank you.